Sejahtera. We are from Group 3, our mini project on four-way traffic light. We got 4 chapters, and for the first chapter is introduction. Chapter 1 Introduction. A shift register is a type of sequential logic circuit used for storing or transferring binary data. In this project, we utilize the JK flip-flops as a shift register. The JK flip-flop is a variation of the bistable multivibrator, essentially a modified version of the SR flip-flop that eliminates the invalid state. When both J and K inputs are high, a clock pulse causes the outputs Q and not Q to toggle between set and reset states. For our project, we use logic gates to create a traffic light system for a four-way intersection. The lights have 3 colors. Red means stop, yellow once the light is about to change, and green means go but with caution. A traffic light controller helps manage road traffic smoothly. In our project, we implemented a shift register using 4 JK flip-flops. The circuit produces 7 different output combinations, controlling the traffic light accordingly. Shift registers can be designed using different types of flip-flops such as SR, JK, and D flip-flops, each with its own configuration and characteristic.
Aim to solve is uncoordinated traffic flow at intersections, which lead to congestion and accidents. Our traffic light system operates in a 7-state sequence, ensuring that each direction gets a fair turn while maintaining order. By automating the traffic light operation, we aim to reduce traffic congestion, minimize collision, and improve road safety. For objective, the first one is to design a four-way traffic light system, and the second one is analyze and design a shift register circuit using 4-bit JK flip-flop to derive the state diagram for its sequence. For scope of works, we have 4 weeks to plan and construct our circuit. According to the guideline, the circuit must include at least 2 flip-flops or shift register to be considered valid. In this project, we utilize a serial in parallel out shift register. The shift register follows a 4-bit binary sequence starting to 000 and progressing to 0111. We designed this project using JK flip-flops and incorporated and NOT gate to control the output for a 4-way traffic light system. A clock signal impulse is applied to the JK flip-flops, ensuring simultaneous output generation and enabling the counter to change state without delay. Additionally, the output of one JK flip-flop is connected to the input of 4 other JK flip-flops to facilitate the desired sequence.
State diagram. Okay, we got 7 states, which is for the first state is 0000, and we got 4 junctions, S1, S2, S3, S4, and the 1, 2, 3, 4 is represent the junction number. Okay, for the first state, the first junction will light up green and the other 3 roads will light up red. And for the second state, the first junction will light up yellow and the other 3 roads will remain red. For the third state, the junction 1 will turn to red. When the junction 1 turn to red, automatically for the junction 2, the green will light up. Then the other 2 remain red. And for the other states, we using the same pattern. Following this, we got the transition table for the JK flip-flops. We use JK flip-flop in our project. We use 4 bits, so we got the 4 flip-flops here. For example, this is presented next state and the transition table for the 4 JK flip-flops. And we here got the K-map for the JK flip-flops. For example, this is our table, and under the table is our Boolean expression. So we got 4J K-map, and then the K is got 4 K-maps. So totally 8 K-maps. And then here our signal to table. For example, G1, G2, G3, G4 is our junction, and G1 for junction 1, G2 for junction 2, and G3 for junction 3, and G4 for junction 4. Same goes to the yellow and red. The color is representing the colors of the lights.
For easiest way to understand. Okay. For this first state, we choose 0, 0, 0, 0, and light for road 1 is green, while others is red. For the second stage, which is 0, 0, 0, 1, light for the first junction yellow, and others remain red. For third stage, the first road turn to red, and automatically the green light for the second road will light up, and the third and fourth roads remain red. Then the following state will follow the same pattern.
Following this, we got K-map and Boolean expression of the signal. For the first green signal, which is G1, G2, G3, and G4. Following that, yellow signal, and then the red signal. So we got 12 K-map for the signals K-map. And this is our circuit.
Development of this project, several issues were encountered that affect the correct operation of the traffic light sequence. One common issue was that the traffic light did not follow the expected sequence or skip state. This was primarily due to incorrect state transition in the shift register. To resolve this, we verified the state transition table and used waveform simulation to track the output of each JK flip-flop at every clock pulse. Additionally, we rechecked the Boolean expression derived from the kernel map to ensure the logic gates were correctly configured. Another issue faced was that the JK flip-flops were not toggling properly, leading to incorrect signal output. This problem was often caused by improper clock synchronization or incorrect wiring of the J and K inputs. To troubleshoot this, we ensure that the clock pulse was consistently applied and check that the flip-flop will receive the correct input signals. If the issue persisted, we manually reset the flip-flops to observe their behavior and identify any faulty transition. Apart from that, while we testing our circuit with Alterabot, we face problem at input which we set as toggle switch, but it seems to not give the output we want. So we did change the input signal to push button, and finally it worked. Lastly, waveform mismatch were observed in the initial testing phase where the expected traffic light timing did not match the real output. The issue was reversed by refining the Boolean expression by adjusting the logic gate configuration. After multiple tests and debugging sessions, we successfully corrected the circuit's logic to ensure the traffic lights operate in the correct sequence. Through carefully troubleshooting and system testing, we were able to refine our design and achieve our fully functional forward traffic light control system using JK flip-flops. This is our waveform result. The circuit function correctly and deliver the expected output. This forward traffic light system consists of 12 output signals, where every set of 3 outputs represent a specific light colors, red, green, and yellow. To generate the required signal pattern, JK flip-flop are utilized within the circuit. These 4 JK flip-flop are interconnected to form a serial in parallel SIPO shift register. Initially, when the input is low, the clock receives a positive edge trigger initiating the process. On the first rising clock edge, G1 green one is activated along with all red light except R1 is red one. At the same time, Y1 is yellow one light up only when both D1 and R1 are off. This sequential pattern continues transition through signal 2, signal 3, and signal 4 before cycling back to signal 1. The overall behavior of this circuit closely resembles the operation of a more state machine, where outputs depend only on the current state and not directly on the input. Discovered that a shift register circuit can be constructed using 4 JK flip-flops. The circuit operates with a 7-bit sequence ranging from 0000 to 0111 in binary to generate the required output. Although the shift register design is somewhat complex, it is relatively easy to understand. Using the knowledge gained uh, through, throughout the semester, we successfully built a four-way traffic light system that meets the given criteria. The circuit was designed based on Boolean expression and JK flip-flops as input components. The only external input provided was the clock impulse, while the J and K inputs of each flip-flop were derived from the outputs of other flip-flops. These outputs were then connected to the traffic light signal. Initially, the circuit's waveform was decorated and contained multiply errors. To resolve these issues, we adjusted the logic gates based on the Boolean expression to generate the correct output waveform. After multiple attempts, we successfully corrected the circuit's output. With these achievements, the mini project's objectives were met. Proper planning, Boolean expression derivation, and block diagram design were essential steps in ensuring the project's success. Add emergency detection feature where ambulance, fire truck, and police car trigger a green light automatically to pass through intersection. Second, implement low power LED traffic light and solar powered system to make the project more eco-friendly and energy efficient. And lastly, replacing flip-flop with a microcontroller like Arduino or PIC for more flexibility and efficiency.
In our mini project, we successfully constructed a 4-bit shift register circuit using ZK flip-flops, which count from 0000 to 0111 to generate the output for a 4-way traffic light system. Although we encountered several challenges during the construction of our circuit, we were able to troubleshoot and resolve the issues effectively. The objective of our project was achieved by implementing 4 jacket flip-flops in the circuit to create the shift register required for the traffic light system. Additionally, we derived the correct Boolean expression from the CapMap based on the state diagram. Using this expression, we designed a block diagram to illustrate how the connected inputs and output function as a traffic light system. By following the given criteria, we successfully developed a 4-way traffic light system using JK flip-flop. In summary, synchronizing the traffic light system is an effective solution to reduce traffic congestion and improve road safety. This project has significant application in controlling and managing traffic, especially in high traffic area. In the future, we aim to refine our design by simplifying the circuit to reduce complexity and enhance its functionality. Additionally, if any challenges arise, we believe that teamwork and patience will help us to overcome them. We hope that this mini project will benefit all users by contributing to safer and more efficient traffic management.